going to be discussing on the enzymes of fatty acid synthesis. So the enzyme of fatty acid synthesis is called fatty acid synthase enzyme. It's a multi-complex enzyme, dimeric multi-complex enzyme made up of 7 enzymes. So these are the enzymes: condensing enzyme, acetyl transacylase, malonyl transacylase, enol reductase, ketoacyl reductase, dehydratase, and thioesterase. So these are the 7 enzymes and one carrier protein. So the carrier protein is called acyl carrier protein. So it's made up of 7 enzymes plus one carrier protein. All of this gives us what we call fatty acid synthase. So as you can see, we have the abbreviations of these enzymes here at your left hand side and the full name at the right. So the full name of this enzymes, of this enzyme, condensing enzyme, and this carrier protein here, acyl carrier protein, is very important because most of the pathway, when we do the video on the pathways, you will see that this is we make use of the abbreviations of this two proteins, this enzyme and the acyl carrier protein. So it will be very important for us taking note of the full names. It's very, very important. So these enzymes are further grouped into units. So we'll take on the units. So as you can see here, we have the units. We have the condensing unit, reducing unit, and the releasing unit. So this this order of arrangement here, and the other units I just called them now. I started with condensing unit, reducing unit, and releasing unit. This is exactly how the fatty acid synthase works. It's condense, reduce, then release. So the major fatty acid actually formed or synthesized during fatty acid synthesis is palmitic acid. Not that other fatty acids are not formed, maybe stearic acid can be formed too, but the major one formed is palmitic acid. So our attention will be more on the palmitic acid. So we'll go to the structure of this. As you can see, sorry, let me say something here. As you can see here that the condensing unit is made up of condensing enzyme, acetyl transacylase, malonyl transacylase. Then the reducing unit is made up of you have a carrier protein there, acyl carrier protein. Remember, it's not an enzyme; it's a carrier protein. Then we have ketoacyl reductase, dehydratase, and enol reductase. Then the releasing unit is made up of just one enzyme, which is thioesterase. Thioesterase. So now we'll move to the structure of this enzyme, this fatty acid synthase enzyme. This is the structure of the enzyme. So as you can see here, this is the releasing unit. And sorry, this is the condensing unit. This is the condensing unit. This is the reducing unit, and this is the releasing unit. As you can see here too, condensing unit, reducing unit, and down here we have the releasing unit. So you can see this. Remember I told you earlier that it's a dimeric multi-enzyme complex, meaning that it has two monomers. This is a monomer or a subunit, and this is a monomer or a subunit. So in this enzyme, two proteins has a thiol group. So which you can see here, this is a thiol group, this is a thiol group. So the protein, one is an enzyme and one is a carrier protein. So this is an enzyme, this is a carrier protein. So this thiol group serve as a hand that they use to hold the intermediates of this fatty acid synthesis. So imagine it as a hand because we're going to they're the main. They will be especially this guy. He'll be the main focus. Especially him. He'll be the main focus. So because the reason why he'll be the main focus is because he is mobile. As ACP is mobile, as carrier protein is mobile, and it has a hand. So this one, and it's not an enzyme, it's a carrier protein. Then this condensing enzyme is an enzyme. It has a hand, but it's not mobile. It's got live step 3, so it should stay at step 3. So please remember that it's very important when we start this pathway. So as you can see, you know what responds for the thiol group in condensing enzyme is the cysteine, like amino acid, and here is what is take 4 prime phosphopanthine. That's what responds for this the thiol group, for this ACP to have the thiol group. So now I've showed you the monomer. So now we'll go to the functional unit. So the functional unit is marked from here down to this place, down to this second, down to the second monomer, from the first monomer to the other monomer. So you get the functional from here downward to here, gives you a functional unit, one functional unit. Then from here downward to here too, gives you a functional unit. You see, this is a functional unit, this is a functional unit. They act independent of each other. The two functional units act independent of each other, don't depend on each other, but you can't have a functional unit without the two monomers. The two monomers must be available to get a functional unit. So one monomer, that means one monomer cannot perform the action of the function of synthesizing a fatty acid. So you must have two monomers to actually be able to synthesize a fatty acid, because you can see here the two monomers contribute to forming the functional groups. So you have two functional groups. So now this fatty acid synthase is actually coded for, the enzymes are coded for by one gene, just one gene are code for these enzymes. So I have a mnemonics that can help us remember this the names of these enzymes here. So go to the mnemonics now. So this is the mnemonics. As you can see here, if you're a football fan, you find this very easy. As you can see, we have Cristiano Eclipse as for condensing enzyme, at for acetyl transilase, Manchester United tripled, malonyl transilase. These three make up the condensing units. Then you have don't hate, the additives, even Ronaldo's for enoyl reductase, kid run for keto acid reductase. This gives you what? Okay, and sorry, remaining one at constant pace, which is acyl carrier protein. The whole of this gives you the reducing unit. Then tell everyone for thioesterase, which gives you the releasing unit. So I guess we are done for today. Thanks for watching, and please press the subscribe button and the notification bell. Thank you for watching.